סת' שוורץ הוא מנהל תוכניות מל"טים למסחור והעברת טכנולוגיה מסינקלר קולג'. נושא הרצאתו, ניהול מל"טים מחוץ לקשר עין, BVLOS.
Hello, I am Seth Schwartz. I am the Program Manager for Commercialization and Technology Transfer of the National UAS Training and Certification Center, part of Sinclair College in Dayton, Ohio. At the National UAS Training and Certification Center, our department works with multiple sectors of the growing UAS industry. Today, I will be concentrating on the applied research and development and advanced simulation fields. Dr. Shepard will be talking about some of the other sections later. We collaborated with the United States Air Force Research Labs and the State of Ohio Department of Transportation's UAS Center to perform the first beyond visual line of sight flight under an FAA COA on April 22nd, 2019. This was a fast project with working through the Air Force's airworthiness process in record time to get the vehicle approved for flight. We flew at the Ohio UAS test range at Springfield Beckley Airport. This is a Class G airspace and is shared with manned aircraft. The airport is located in the southwest portion of Ohio. The chart to the right is an aviation sectional chart with the airport visible just off center, showing how close we are in proximity to other airports, as well as Wright-Patterson Air Force Base. The lower image on the left is an aerial view of the airport. For this mission, we flew off the middle of the shorter runway. The larger runway was open for flights and manned aircraft at the time. The sky vision system that the AFRL uses for the test range contains the STARS Elite system, which uses existing ground-based radars that are in place for air traffic controllers. They use these to be able to monitor manned air traffic, and it also ingests the telemetry of UAVs in the test range so that they have the ability to detect and avoid any possible air traffic situation. While we are able to see the air traffic controllers do not see our UAV traffic, and they do not get a feed from our system. This area of Ohio is approximately 1,000 MSL. Flying under the FAA Part 107 regulation, UAV pilots are limited to flying under 400 feet above ground level. The beyond visual line of sight test range starts at 1,000 AGL. These two radar images show that we have a lot better probability of detection at higher elevations, so that the STARS system monitors can have a greater situational awareness. We flew the mission at elevations between 2,000 and 3,000 AGL in mixed use airspace, so we could and did have manned aircraft flying in the same area. The UAS test range is a designated area approximately 200 square miles south and southeast of the airport. The STARS system operators are able to monitor the airspace and have it divided into three basic areas: surveillance, threat, and operational. In the lower image on the left, we have the operational area. The smaller green box is the visual line of sight COA flight area. We use this area for the launch and recovery portions of this mission. We also use this area to transition to the higher elevation for the beyond visual line of sight flight. The pilot will have the UAV climb in a spiral pattern in this area until reaching the operational altitude and then transition to the mission. Then we'll also reverse this flight plan to come in for landing. The upper image shows the areas where the STARS system operators monitor other aircraft and will prepare to take action when the aircraft move from the surveillance area into the threat area. The image of the radar shows an example of the STARS system with the UAV designated RPA-001, as well as a manned aircraft INT for intruder, with the altitude, direction, and speed of the aircraft. The STARS system operators give the UAV pilot directions so that we can avoid any conflict with the manned aircraft. We can see the other aircraft, so it is our responsibility to detect and avoid any other traffic. The ground-based detect and avoid mobile unit has multiple redundant communication systems, including radio, cellular, and VoIP, to be able to communicate with the air traffic controller, in this case, Columbus, as well as the remote ground control stations for the location we are flying from, and if needed, the manned aircraft. We used the Centera Vario for this mission. We selected this UAV because the SkyVision system originally was designed to work with the Piccolo autopilot. We have worked on a separate project since this original flight to assist with a universal translator so that other autopilot systems can be used in the UAS test range beyond visual line of sight operations. The Vario is a hand-launched small fixed-wing UAV that was originally designed as a ISR operations. Next, we're going to have a short video that was put together by the Ohio Department of Transportation to showcase this project with the multiple groups that collaborated. I'll try to narrate through a little bit of this. The Vario we used, we painted red and white for the Sinclair school colors. This was the first of a few different flights. We flew again next couple days. We had a well-trained flight crew. Dr. Shepard here is launching the Vario. Being a single motor airplane, it does torque a little bit at first, but it levels out and flies very stable pretty rapidly. We collaborated with multiple groups, the Air Force Research Lab, State of Ohio Department of Transportation, various government contractors. The flight test area has been set up with a intranet of fiber optic cable. So we had contractors in establishing the fiber network. It is now connected to ORNet, the Ohio State network that gives us the ability to reach out to the internet now. There was a lot of collaboration for this project. Here we're setting up the equipment. It does take a little bit of time, so luckily they did speed up the video. We are flying at a remote spot away from the SkyVision vehicle. We were using our own mobile ground command center just as a backup visual. We have the ability, we have 3 computers inside plus the external monitors. So as a secondary system, not required for the flights, we had a secondary ADS-B radar system just for extra situational awareness. Dr. Shepard was setting up directional flags for us so we could make sure we kept the antenna aimed properly. We're using a directional antenna because we flew out about 3 miles away from us and back. We had designated holding loiter spots, so the angle of the antenna made it so we did not need a tracking antenna for this mission, but we wanted a little bit better range, so we used the panel antennas for direction. Yeah. Yeah. So it was a very fun project that we worked on, and we were very proud to have been part of this, being able to do the flights for the Department of Transportation here in Ohio, working with them and the Air Force Research Lab, along with the other partners on this project. Thank you very much. Yep, bye.